In this lesson, we're going to look at atomic mass units to understand what they are, look at the properties, including mass and charge, of the subatomic particles, so protons, neutrons, and electrons. And then we're going to talk about the atomic number and what that means about a particular atom. First, we're going to define atomic mass unit, and we use the abbreviation U. So if we look at one atomic mass unit, or 1 U, it is equal to 1/12 the mass of a carbon-12 atom. And we'll talk more about what that carbon-12 means later on, but know that this has a value. We use it in terms of atomic mass units, or U, because it's easier to talk about, because 1 U, or 1 atomic mass unit, has a mass of 1.661 times 10 to the minus 24 grams. So it's a little bit easier to talk about things in terms of atomic mass units than it is to talk about them in terms of grams when the values are so small. Let's look at the subatomic particles. First, we're going to talk about the abbreviation we use for these. So we use P, N, and E with a minus sign to represent protons, neutrons, and electrons. When we look at the charges on each of these species, we see that protons have a positive charge, neutrons have a neutral charge, so a charge of 0, and electrons have a negative charge. We can also look at the relative masses of each of these. So a proton has a mass of approximately 1 U, or 1 atomic mass unit. A neutron also has the mass of 1 U. So they're approximately the same, slightly different, but pretty close to one another. And then an electron has the mass of 0.00055 U. So much smaller than the mass of a proton or neutron. So one way to think about this is if you have $1 and I give you another dollar, I've doubled your money. You're going to notice that. That's a significant change for you. If you have $1,000 and I give you $1, you're probably not going to notice this that much. And so the same thing is true here. When we look at the mass of protons and neutrons, they're so much heavier than an electron that the mass of an electron contributes very little to the mass of an atom. So when we talk about the mass of an atom, we're primarily looking at the mass of the protons and the neutrons. Looking at the example of a helium atom, we see that we have protons and neutrons in the nucleus. The bulk of the mass of an atom is in that nucleus. That's also where all the positive charge is. And then outside that nucleus, we have the electron and the negative charge. Which particle has the smallest mass? So electrons have the smallest mass. They are much smaller. So the mass of the proton, mass of the neutron, approximately equal to one another. The mass of a proton to the mass of an electron is much greater. So it's about 1836 to 1. So the mass of a proton is 1,836 times bigger than the mass of an electron. Next, we want to talk about atomic number. Every element has an atomic number, and we're going to see this in a couple of ways. We're going to see it on the periodic table, and we're also going to see it in what we call the isotopic symbol, or this symbol for an atom. So when we look at a periodic table, we'll see there's some information that we have the symbol. Sometimes you'll see the name, sometimes you won't. We'll see a whole number, which is our atomic number, and we'll see a number that's not a whole number, that is the mass of an atom. And we'll talk more about that one later on. Right now, we're just focusing on the atomic number. Now note that different periodic tables will put things in different places, but you can always find the atomic number because it's always going to be a whole number, and you'll always see that those numbers go sequentially, 1, 2, 3, 4, 5. When we want to write out a symbol or a shorthand notation for a particular atom, the atomic number is always subscripted to the left of the chemical symbol. So this number on the bottom is the atomic number for beryllium, and we see that's the number we see on the periodic table. The atomic number is a very useful piece of information because it tells us the number of protons in an atom of that element. And what we'll see is that it doesn't matter what the element is, the number of protons is always the same. If I didn't have 4 protons, I wouldn't have beryllium. I'd have a different substance. So the atomic number equals the number of protons, and that never changes for a particular element. What is the atomic number of fluorine? We see the 9 in the periodic table for fluorine, and that is the atomic number of fluorine. How many proteins are in an atom of fluorine? And that will also be 9. The atomic number equals the number of protons in an atom. The periodic table is in order of those atomic numbers. If there are 9 protons in an atom, it must be fluorine. It can't be anything else.